Hi, thanks for joining us today for this short presentation brought to you by the Oregon Housing and Community Services Multifamily Energy Program. Today's short presentation is part of our Emerging Technologies series and will cover variable refrigerant flow heat pumps, also known as VRF heat pumps. So what is a variable refrigerant flow or VRF system? We're often asked the difference between a true VRF system and a mini-split system, or what is often referred to as a multi-split system when you have several mini-splits working together. It is true that the mini-split or multi-split system does use variable refrigerant flow, but the major difference is that each outdoor unit can only control 2 to 8 indoor units with a multi-split system. It is part of the core design of these systems. They really are designed to be more of a 1-to-1 or 1-to-2 outdoor to indoor unit system. It allows you to really independently work in either multifamily or single family scenarios or even small business and really control small areas at a time. Whereas the full variable refrigerant flow system operates the same basic principles of multi-split, but you can actually heat and cool at the same time, which we'll go into in just a minute in different zones of the building, as well as a single outdoor unit can control up to as many as 48 indoor units. So you can begin to imagine the application of a full VRF system is going to lean more towards multifamily and commercial properties, where the desire is to control large amounts of a building or multiple zones with a single outdoor unit. So let's visually look at the difference between mini-split or multi-split heat pumps and a VRF heat pump. On the left side of the screen, you'll see the mini-split heat pump system. In this scenario, you have a set of refrigerant lines, sometimes referred to as the hot gas and suction line or the high pressure gas and low pressure gas lines. And you have a set that runs independently from the outdoor unit to each indoor unit or head. Now, there are some configurations and scenarios where you may have a single set of lines coming off of the outdoor unit going into a distribution box, which will then deliver to each individual interior unit. That is sometimes determined by the specifics of the equipment and can also be mandated by codes and regulations in order to limit how many different places where you may have connections. On the right side of our screen, we have the VRF heat pump. And you'll notice just looking at it, one of the key differences is you're going to have a single, in this two-pipe system, a single supply line and a single suction line, or a single hot gas line and a single low pressure gas line. What's unique about this is, while a bit of an oversimplification, it's designed a bit like a plumbing supply system, where you have a main trunk and branches that are going to go to each indoor head or indoor unit. This allows for a lot less refrigerant piping to be run through a building. And this is also one of the ways where, because of the way the system is designed and the volume of refrigerant the outdoor unit is capable of moving, you can have a great many more heads or indoor units connected to a single outdoor unit. Within these VRF systems, we have both two-pipe and three-pipe models. Let's start first with a two-pipe model. This is most similar to the traditional mini-split or multi-split system that we're familiar with. I mentioned this earlier in the previous image, where we have our refrigerant piping that comes in a high pressure gas and low pressure gas side of the equation, and it comes out of the outdoor unit and independently goes to each of the indoor units. These systems can be controlled individually in each zone. So in the diagram that you see here, you see some wired control panels and an infrared remote control. Each one of them can be controlled individually, which would probably be our preference in a multifamily scenario. These systems, however, can also be controlled by a centralized controller, which makes them a little different than a lot of other multi-split systems. And this may be much more common in a commercial application where you'd like to have a central controller truly determining the temperatures and air movement in each of the different zones that this is being addressed. So this is our traditional two-pipe system. It works very well, very high efficient, but it works very similar to a multi-split system, just with a lot fewer refrigeration lines running. In this scenario, the indoor units can be either heating or cooling in most cases. In the scenario we have on the screen now, we're looking at the three-pipe VRF system, also referred to as a heat recovery system. In this scenario, we have two gas lines and a liquid line, hence the three-line system. Remember, all heat pumps work by moving heat from one area to another through the processes of compression, expansion, and heat exchange. In a traditional system, when heat is released in a building, there must be some waste cool released from the outdoor unit to the outside. In these heat recovery systems, however, that waste cool is utilized inside the building in order to cool a different zone. Essentially, a way to put this is an indoor unit requiring heating will open its hot gas or high pressure line and its liquid line valves and will act as a condenser so that we're releasing heat into the unit and waste cooled has to go somewhere. While instead of putting the waste cooled outside, we're able to use this high pressure liquid line to potentially produce or release the cool air into the building. So an indoor unit requiring cooling would open its liquid line and its suction line or the low pressure gas line. In this scenario, we're actually producing waste cool producing cool into the building, and then waste heat needs to go somewhere. By using this three-pipe system, we can actually be heating and cooling different zones of the building at the same time with that single outdoor unit. Should you not need, with a three-pipe system, to be heating and cooling both simultaneously, then the waste heat or the waste cool would work much like a traditional system and would be expunged into the outdoors through the outdoor unit. So why is a VRF system a good fit for multifamily buildings? For one, if we imagine what we're comparing this against, let's compare this to upgrading to package terminal heat pumps. So package terminal heat pump is that usually the large block unit that would go through an exterior wall of the building, really often under a window. Just imagine the size of that penetration if you're upgrading from electric resistance to package terminal heat pumps. You're needing to put a large penetration in every unit or every zone that you're intending to heat and cool throughout the building. So it's quite a bit of additional disruption to the exterior to put in package terminal heat pumps. It does provide the ability to do zonal control, with some units being heated and some units being cooled. This is truly where some of the special sauce with VRF system comes into play. For tall buildings where you may need heating on the top floor and cooling on the bottom floor or vice versa, or buildings where the south side may need cooling and the north side may need heating on the same day at the same time, these VRF systems are really a nice approach to being able to deliver this. They also deliver higher efficiency than package terminal heat pumps and much higher efficiency than electric resistance heat. So if we're looking to maximize the energy efficiency, or in other words, lower the bills of the occupants the most, a VRF system can be the highest efficient system on the market to really do this for ourselves. Finally, VRF systems can excel at a variety of outdoor temperatures and at a variety of loads inside the building. So whether we're talking about producing useful heat even in very cool temperatures or useful cooling power even in very high temperatures, VRF systems work terrifically. They also work really well and very efficiently in what we consider a low load scenario, or when it's just a little bit cooler or a little bit warmer inside of our units than it is outside. That effectiveness throughout a wider range of outdoor temperatures and different load profiles of our building really make VRF systems special and allow them to operate at their peak or close to peak efficiency at a wider range of temperatures. Now, if we compare these to switching to a traditional ductless mini split system or a multi-split system, again, one of the big differences is going to be this ability to provide heating and cooling simultaneously with the same outdoor unit. If we had a traditional multi-split or mini-split system, we would have to do this by having a one-to-one system for every unit in the building. So that means if you have 48 units in your multifamily building, you would need to have 48 outdoor units on the roof compared to potentially one outdoor unit for the VRF system. So quite a bit of difference. They also can be a little bit more efficient than the base multi-split system. There are some considerations to take into account when we put these in, and their considerations are a little different with new construction versus retrofit. So I really want to focus on, again, building disruption and zonal control here for the next minute or two. For building disruption, in new construction, you only have to design a 3-inch hole to the exterior, and then you can design the refrigerant, the 3-pipe system, to run through walls, between floors, and chases to each individual unit, which anyone who's had to compare this to, say, a ducted system can imagine the great difference in how we actually design and allow for space to be much more useful in our buildings when it's not being taken up with large HVAC chases. For an existing building, again, one penetration versus multiple penetrations is a large benefit when renovating or retrofitting a building. It is best suited when we're also going to be doing some renovation and retrofitting on the interior. That way, that will allow us to open ceilings, open walls, etc., to run these refrigerant lines and liquid lines throughout the building. That is something that we want to be able to consider if we're looking at a renovation or retrofit that's not going to have much disruption on the interior of the building. We have to ask ourselves if the VRF system is the correct or best approach. I might say that the integrity of the exterior of the building is such of high value that when I'm forced to look at a decision like this, I'm going to strongly weigh that 1 or 2 external penetrations versus having to do some renovation to the interior of the building. When we talk about zonal control, if we're looking at a VRF system and we're designing new construction, we could have as little as 2 outdoor units providing zonal control for most of the different multifamily buildings that are being newly built. That's really terrific to think about only those 2 outdoor units, both in terms of price and use of space on the exterior. To do the same number of indoor units with a multi-split system, you would have to use at least 6 outdoor units. So triple, in this case, the number of outdoor units. So that's space required, that's penetrations through the building, and if you used 6 multi-split systems, each of the units that are connected, you would only be able to remember heat all at the same time or cool all at the same time per outdoor unit. Whereas with a VRF system, again, you have that flexibility for zonal control. When we compare this to existing buildings, again, we have the great zone. You can have zonal control with package terminal heat pumps. You can have zonal control with electric resistance heat. You're simply not going to get that heating and cooling potentially simultaneously. Now, there are some realities to consider here. VRF systems are more expensive. They typically do cost, somewhere in the range of 24, 25% more than a ductless heat pump multi-split system for a building in new construction. And in existing, if we're comparing to package terminal heat pumps, they can be as much as 90% more expensive. Because of the way the systems are designed, where they do not have a home run refrigerant line going directly from the indoor unit to the outdoor unit, and instead they have a branching configuration of refrigerant lines, there are also some additional safety requirements that come into play. And the larger the building, the more likely these safety requirements come into play, because there are limitations to how much potential refrigerant leakage you could have based on how many different connections you have. And it's a bit of a labyrinth of codes and standards, but there are codes and standards specifically designed to protect both the installers and the occupants of buildings from any potential future refrigerant leak. And these are things that shouldn't scare anyone off from considering VRF, but should absolutely be considered. There will be safety considerations and cost considerations on the front end of doing this. On the other side, the benefits, you will have better zonal control, fewer building penetrations, higher efficiency systems. So why consider VRF systems now? These aren't exactly new. We've had these in our buildings for dozens of years in North America, but traditionally they've been in large commercial buildings. One of the reasons why is we simply have not had the installer network truly available to really support an expanding network of installations. We now have trained installers in a great many more places, and that actually leads to both the cost of the install as well as some of those safety concerns I mentioned. With a wider installer network, we're starting to see VRF systems being explored much more in multifamily. In fact, on the East Coast, this has become a preferred method for heating and cooling multifamily new construction buildings. Second, the efficiencies and performances, and now I'm going to talk for both mini-split or multi-split systems and VRF systems, have progressed tremendously over the past decade or so. And I'm talking both the actual efficiency or the coefficient of performance, and that has to do with how much bang am I getting for my buck. But we're also talking about performance that I mentioned earlier, being able to operate at very low temperatures, very high temperatures, or at that partial load condition where I just need a little cooling or a little heating. Those efficiencies and performances through investment from our manufacturers and through enhanced testing procedures have really pushed along what these systems can do. So we're nearing the real peak of performance from these types of systems. On top of all this, we're putting better and better envelopes out there. So having the need for pieces of equipment that can operate when it's very cold outside or when we have only a little bit of a load, that need has really pushed and opened the window for these VRF systems to be the right solution because we're building homes and buildings with better envelopes and because we're renovating and retrofitting our buildings to have better and better envelopes. This really does make these systems the preferred system for a very efficient building. And finally, when we look at the amenities race in the multifamily realm, cooling is no longer just considered a plus. It is now becoming an expected amenity. There was a recent article in a magazine looking at amenities in the Northwest, and while closet space, bike storage, things of that were critical, considered an expectation now is cooling in every unit. So when we think about that, compare this to electric resistance or to some of the other systems that are out there, a VRF system that could allow heating and cooling simultaneously in a building really does speak to what future occupants are asking for. I want to wrap up by talking about what this means for incentives in our program. Our program is tiered particularly in the whole building scenario to reward better in terms of how many dollars per kWh you save by getting more and more efficient buildings. As it turns out, you can get to that 20% level pretty quickly with some minor envelope improvements and a VRF system. And if you were to do major envelope improvements, as well as use something like a VRF system, the modeling can actually show that you're getting above 30% compared to the baseline. And for remembrance, in new construction, code is our baseline, and the existing conditions of the building would be the baseline for the retrofit. So this really is a nice benefit. You not only get a more efficient building and one that will have lower bills for your occupants, you actually get to save and get a better incentive rate depending on what category of savings you're in. So VRF systems are really a great way to help boost you to that tier 2 or tier 3 savings level. And with that, I want to thank you very much for spending some of your time today with us. Again, this presentation has been brought to you by the Oregon Housing and Community Services Multifamily Energy Program. This has been the Emerging Technology Series variable refrigerant flow. And please stay tuned for future small presentations, and we look forward to you joining us then.